These topics which we will cover today are what makes a project feasible, key disciplines and key processes, how we can align these, and do we need to align these all processes. Then we'll discuss about the different activities in each development phase. We'll discuss about the phases as well. And then we'll cover our main topic of project initiation and then its concept and then select phase and then feed phase and later on execution. There are different activities which are integrated together in a plan. So we'll have a look of these activities in a plan as well, and then some formats of the project protocols we'll go through, and these are as mentioned here. You can have a look on this. So we'll go through all this, and at last we'll see how the project is interfaced with the O&M. So we start with some refresh of our mind with the what makes a project feasible. We know for every project, for every business, there is a simple rule that if you want to go for a business, you go for a profit and a margin in the profit on the investment. So the simple equation here, you can see that we have profit is always equal to the difference of revenue and cost. In case of oil, we'll have a price of oil uh, from WTI or whatever you are following the authority. And then you have to multiply it with the barrels, number of barrels, and LOE is the lease or operation expense. So the difference of these two will give you a profit. The second factor is break even. Break even is usually you get when the revenue becomes equal to the cost. So just by it shows zero on the right side. So you have this equation, but you need to know that how much barrels you have to produce for this. So you need to know some factor to reach up to that break even point in a specific time. The factor three is the profit, but with other associated like associated gas and condensate. So we have to add these things as well with the their price, and multiply it with the barrels. So we get the greater margin in this case. So we have refreshed this with this equation, but this is not the finish of how we can calculate or how we can see that the project is feasible. So usually to make a decision with other things which we will see in the coming slides. The important thing is the investment decision criteria. So analysts, they use several important criteria to evaluate capital investment. The most or the two most important areas or measures of whether a project is profitable or unprofitable. These are the net present value (NPV) and internal rate of return. These are two very important, but there are four other areas as well: the payback period and discounted payback period. We know average accounting rate of return and profitability index. These are also some areas, but usually, if these two factors are satisfied, then we have to uh, rely on them, but we can go in detail with other areas as well. So in today's, we will see with these two factors. Now, once the uh, decision is made, but there are some occasions when during the execution phase, there is a possibility that during the reviews or when the questions or technical questions are asked, so and occasionally projects in mid development can be shut down or postponed. So this is the possibility, and we have experience of this. You know about recently in 2015, 14, 15, when the oil prices dropped drastically. Similarly, it was happened in 2008 and 2009, and many projects, those were approved for development, were cancelled. And IEA, the International Energy Agency, they reported that in 2009, since October 2008, so more than 20 planned large-scale upstream oil and gas projects, uh, which were of about the production of 2 million barrel per day or more than that of oil production capacity, were deferred or indefinitely or cancelled. So this is the situation. But along with this, once the FID is made, the project is handed over to the development team and project execution begins. So with this background, we move forward and we see how to calculate the NPV and IRR to understand that uh, for the engineers, that what is NPV. You see here on the left side, there is an equation which shows that NPV is equal to the sum of cash flow, which is the cash flow in and with the time passage of time. At the time zero, you basically disburse amount for investment, maybe in one go, or that is outlay, and that is always negative. So the cash flow means the after the production when you get the revenue. So sum of all these for each year, and for each year you have to divide it with the discount value and the rate of discount value as we will discuss. Usually it is taken 10%. So with each year you have this equation here that you can understand that CFT is basically a cash flow after tax at time t, and R is the rate of return for the investment. So disbursement is shown as outlay here. For you can understand with the simple example here that for an investment where you have a company has invested euro 50 million, which is shown, you can see here that it is about 50 million euro here. This is first one go investment, one go investment. So you have yearly around uh, 16 million euro cash in for 4 years. So for each year you get 16 million euro, and the fifth year you get 20 million euro. So you sum up all this with the discounted value factor, and you see the with the formula which you can see for each year, the t, you are changing the time, the year number of year is going to be incremented. So what you get is a positive value. You get the 13.136 million euro, which is a positive value. The second factor, which is IRR, for a project with one investment cost like this one. So made initially, the IRR is the discount rate that makes the present value of the future after tax cash flows equal that investment outlay. What does it mean? It means that when your revenue, the total revenue, becomes equal to the total investment, uh, but you don't know at what rate it will be equal to zero. So you need to know the rate, because at 10% you see it is giving you 60, it is giving you a 13.136. So it should be zero, means the break-even point. IRR is internal rate of return when your expenses or whatever the capital cost, you got it back. So at what value you will get it. So you see in this equation, it is a little bit harder to calculate it because of the power, which is increasing, and the equation becomes complex. So what we do for this, there are iteration processes, and I can show you here that you see on the right side, okay, here, trial and error process for finding the uh, discount rate. So when we had for 10% discount rate, we got 13.136. And then we put 20% discount rate, we go for minus value, so it is not okay. So we decrease it. We go to 19 as our discount rate. So we get this value. So for each, now we will increase because we see that in between this there can be a zero. So we increase this point, and when we reach to 19.52, we get zero. This is a little bit complicated, but usually now we are in the age when we can calculate it on Excel sheet, and with the different software, you can get this value as well. So I can show you that as well later on. So this is basically this value IRR means the internal operator return on this uh, rate in the same equation. So if NPV is greater than zero, you can invest. Okay, if it is less than zero, means negative, you cannot. So this is a simple rule here for the investment. And the second, if the IRR is greater than R, means IRR, okay, this 19.452 is greater than 10%, because it is the break-even value. It should be greater than this in this case. So you can invest. Or if it is less than 10%, you cannot invest, because 10% is already, the things. Why the 10% is fixed? So that is a different topic, and we can see a little bit in the next slide that what is that. The required rate of return is often termed as the hurdle rate. You see here, hurdle rate. So it is top to the 10%, 19.52% is top to 10%. So this difference is basically the hurdle rate, and that a project's IRR must exceed for the project to be accepted. So in this case, we have understood this. Now we'll see in our case, uh, to understand the first equation, the margin of revenue and cost. You just see this table. Let's for a project of Chevron, Brazil, the economics you can just understand here. You see here the reserves for this project is 250 million. Okay, and the production per day is 100,000 barrels per day. Production per year you will multiply it with 365, and we'll get it. The cost of capital, which this project is estimated, is this value you see here. It's about 3 billion. Now you go for the capital cost, which is, you can see here that capital cost is $12 per barrel. Operating cost we have seen $10. Okay, the total delivered cost, this is the total delivered cost for per barrel, is 22. For this kind of crude, which WTI price which for the crude is 70, and for this kind of crude it is discounted for 15%, and you get $59.5. You can sell this. So when you have this value, this is the revenue, and you deducted the delivered cost, you get the possible gross margin, that is $37.5 of first equation. This is just to understand. Okay, so the second is the oil development project expected cash flow. You see here, it can be a different project maybe. So you see here investment cash flow. There are three columns: investment cash flow, operating cash flow, and then you see the net operating cash flow here. How you get it? You see, for the first year, and from 0 point time to the next year, and then remaining years, 2 years, we have this project has spent exploration fee development this amount, and then for upstream development this amount, and pipeline and surface facilities this amount, and next 4 to 5 years they are spending for the project, and these 2 millions for each year they are spending for maybe workover or other. This capital cost is reserved for that. So the total cost for each year is here. The capital cost is here. Now, operating cash flow, you have that you need to know the oil price, that is $20 per barrel, and you have the production for each year, which has started in this year. This you can see this is your production, millions of barrels. So you get the gross value of revenue by multiplying these two. You get this value. You multiply this two, you will get this value. Multiply by this two, you will get this value. So you get the gross revenue here. You get it. So operating cost, how you get it? Your cost per barrel for this year is 6.2, and for each year it is a little bit change. So operating cost is going to be changed. So operating expense, how you get it? You multiply this value, okay, by with production. So you get 3.5. You multiply this value 2.6 with the production, you get this value. So you get all these values multiplying operating cost with the production. So you get all these values, and then net operating earnings. How you get it? With the difference of the first equation, revenue minus the operating expense, 11.4 minus 3.5, 122 minus 15.9. You get all these values. So you get all these values here. Okay. So this is net operating earnings. Now net operating cash flow, how you get it? You see these are in brackets. So if all these are outlay, okay, the capital cost, and all these are cash in. Okay, right? So we'll add all these values, but we don't know the discount factor. There's a simple margins which we can see here in this table.